Hello everyone. Today in this video I am going to talk about organic chemistry. What is organic chemistry? Is the study of carbon compounds. Animals, plants and other form of life consist of organic compounds like nucleic acid, protein, fats, carbohydrate, enzymes, vitamins and hormones are all organic compounds. The second important branch, biochemistry, was developed later as the study of the chemical compounds and reactions in living cells. Friend, scientists had originally thought that organic compounds contain a vital force due to their natural origin. This was disproved by Wohler in 1828. Wohler was able to make urea, a carbon compound in human urine, in the laboratory from minerals. Organic chemistry is an enormous field. In this session, we will investigate some of the fundamental concepts. So, bonding in organic compounds. Beside carbon, the most common elements in organic compounds are hydrogen, oxygen, nitrogen, sulfur, and halogens. All of the preceding elements are nonmetals. Therefore, organic compounds have covalent bonding. Any structural formula that obey the bonding rules in the following tables probably represent a possible compound. A drawn structure that breaks the bonding rule is unlikely to exist. Numbers and types of bond for the compound elements in organic compounds. Application of the octet rule indicates that these elements should bond as shown below. You can see the carbon, nitrogen, oxygen and hydrogen. Number of bonds 4, 3, 2, 1. Distribution of total number of bonds and examples 4 single bonds, 2 single and 1 double bond and 1 single, 1 triple bonds. In case of nitrogen 3 single, 1 double and 1 triple. In case of oxygen 2 single, 1 double and in case of hydrogen, 1 single only. Now identifying valid and incorrect structural formula and examples you can see here. So two structural formula are known above. One does not represent a real compounds. You can see the A. In structure A, each hydrogen and halogens has one bond, each carbon has 4 bonds and each oxygens have 2 bonds. So this is the valid structure. So identifying valid and incorrect structure formula and examples here you can see. As we examine B, we note that each hydrogen has 1 bond, each carbon has 4 bonds and nitrogen has 3 bonds, but the oxygen has 3 bonds. So oxygen should only have 2 bonds. Therefore, it is not a valid structure. If it is valid, when you give the positive charge on oxygens. Now identifying the incorrect structure formula here. Check the structure formula above number of bonds to each atom and determine whether any bonding rules are violated. Then oxygen should have 2 bonds, carbon should have 4 bonds. So each carbon should have 4 bonds and each nitrogen should have 3 bonds. So this is not a valid structure for caffeine. Now hydrocarbons. Hydrocarbons are the most simple organic compounds. Hydrocarbon contains only carbon and hydrogen. For classification purposes, all other organic compounds are considered derivatives of hydrocarbons. So hydrocarbons can be divided into aromatic or aliphatic hydrocarbons. So this is the classifications. Aliphatic, aromatic, now aliphatic alkanes, cycloalkanes, alkenes, alkynes like this. Now aromatic hydrocarbons contains 1 or more benzene ring. Is the most important aromatic hydrocarbon is benzene. It is a clear, colorless liquid with a distinct odor and is a carcinogen, cancer causing agent. Traditional Lewis est. Structural formula and shorthand symbols. The Lewis structure and Kekulé symbol Both indicate that the carbon in the ring have the alternative double bonds, single bond. You can see the presentations. Now other aromatic hydrocarbon, toluene is used in modeling glue, naphthalene is used in mothballs, and phenanthrene are used in the synthesis of dyes, explosive and trucks. These are the structure. So benzene representation. Benzene representation having the flat molecules with 6 delocalization electrons forming an cloud above and below the plane of the ring. Properties of the benzene molecule and advanced bonding theory indicate this structure. The 6 electrons appears to be shared by all the carbon atom in the ring. So when other atoms are substituted from the hydrogens in the benzene ring, so vast array of other compound can be produced. This is the structure of TNT, trinitrotoluene. Drawing a structure for benzene derivative, an example, drawing the structure formula for 1,3-dibromobenzene. First draw a benzene ring like this and then attach a bromine atom to the carbon atom at the ring position you choose to be 1 like this, and then third attach a second dibromine atom to the ring position 3. You may number either clockwise or counterclockwise from carbon 1 and you have the answer 1,3-dibromobenzenes. So structure for the benzene derivative confidence exercise. Which of the models below most accurately represent the hydrogen cyanide molecules? So carbon is B only has the 3 bonds, carbon in C only has the 2 bonds and nitrogen only has 1, C in D only has 3 bonds and nitrogen only has the 2 bonds. Therefore, A appears to be the most accurate representation of the hydrogen cyanide molecules like this. So N has 3 bonds and carbon has 4 bonds, hydrogen has 1. Now drawing a structure for benzene derivatives, confidence exercise. Draw a benzene ring, attach a chlorine atom to the carbon atom at the ring position you choose to be number 1, attach a fluorine atom to ring position 2 and you have the answer 1-chloro-2-fluorobenzenes. Aliphatic hydrocarbons are hydrocarbons having no benzene ring. Aliphatic hydrocarbons can be divided into 4 major divisions: alkanes, cycloalkanes, alkenes and alkynes. So this is the classification. So alkanes are hydrocarbons that contains only a single bond. Alkanes are said to be saturated hydrocarbon because their hydrogen content is at the maximum. Alkanes general formula, the name of alkanes all in A&E, methane, butane are gases, methane to butane, and pentane to 17 carbon are liquids and 18 to higher are solid. So first 8 members of the alkane series all satisfy the general formula like this. So visualization of alkane structure, that is the structural formula, a graphical representation of the way atoms are connected. Condensed structure formula save time, space and are convenient. And ball and stick model, 3D model that can be built by a student. Studies. Models of the 3 alkanes. Names, structure formula, condensed formula and ball and stick model. You can see the presentations 3, 1, 1, 2, 3, 1, 2, 3 like that. Now methane tetrahedral geometry, ball and stick and space filling model. Carbons 4 single bond form a angles of 190 degree, 190.5 degree. So methane primary component of the natural gas, propane and butane primary component of the bottle gas, and gasoline, pentane to decane. Kerosene alkanes with the N is equal to 10 to 16. So alkane with N greater than 16, diesel fuel oil, petroleum, jelly, paraffin wax, lubricating oil and asphalt. So alkane products, alkane are also found in paints, plastics, drug, detergent, insecticide and cosmetics. Only 6% of petroleum consumed goes into making these products. The remaining 94% of the petroleum is burned as one of the various energy related products Although alkanes are highly combustible and they are otherwise not very reactive, you know that. Any reactive would require the breaking of the strong CH-NCC bond. So, what is the alkyl groups? Alkyl group contains one less hydrogen than corresponding alkane. In naming the groups, the AN is dropped and YL is added. For example, methane become methyl and enhanced become ethane become ethyl. So, alkyl group, this group does not exist independently but occurs bonded to the another atom or molecules. So, constitutional isomers, compounds that have the same molecular formula but different structure formula. In the case of many alkanes, there is a more than one way to arrange the atom. For example, butane and isobutane. Both of these alkanes have the molecular formula C4H10, but their structure formula and arrangement is quite different. So, continuous chain or straight chain structure and branch chain structure, you can see the ball and stick model. Constitutional isomer may exist whether it is possible to construct a different structure arrangement using the same number and types of atom without violating the octet rule. In other words, some atoms may be connected to one another in different but valid ways. So, number of possible isomers of alkane, you can see, though 3 carbon only one, but after 4, 2, 5, 3, 6, 5, 7, 9, 8, 18, 9, 35, 10, 75. You can see here C50 is 32, 4347 total isomers. C20 is 22, this much, and 30 is 2. So, carbon atom can bond in many different ways. Now, organic compound nomenclature. Due to the large number, variety and complexity of organic compound, a consistent method for nomenclature has been developed. Now, IUPAC system of the nomenclature for alkanes. Compound is named as derivatives of the long continuous chain of carbon. Position and name of the substituent. If necessary, substituent name alphabetically. More than one of the same type substituent di, tri, tetra. The carbon atoms on the main chain are numbered by continuing from the end of the chain nearest the substituent. Each substituent must have a number. And examples of to consider. A longest continuous chain of carbon atom is 5. Therefore, the compound is a pentane, derivative with attached methyl group. Start numbering from and nearest the substituent. The methyl group is in the second position. The compound name is 2-methyl pentane. Here you can see the formula of substituent and name of the substituent: bromo, chloro, fluoro, iodo, methyl, ethyl. So, draw the structure formula of 2,3-dimethyl-hexane. Note the end name is hexane and draw the continuous chain of the 6 carbon atom with 4 bonds around the each. You can see like this. You can arrange 2,3-dimethyl-hexane. So, same way you can draw another molecules like 2,2-trimethyl-pentane. So, this is the 2,2-trimethyl-pentane ball and stick model. Cycloalkane. Member of the cycloalkane groups possess a ring of carbon atom. The general formula CnH2n. Each carbon atom is bonded to a total 4 carbon or hydrogen atom. The smallest possible ring consists of cyclopropane. So, you can see the 3 types of drawing. First, for cycloalkanes. Draw the geometry figures indicated by the compound's name. Pentane, 1-chloro-2-methyl cyclopentane. This is the ethene general formula and begins with the ethene, that is ethylene. So, some member of alkene series like this. Now, naming of alkene, ane suffix for the corresponding alkane is changed to ene for alkenes. The number preceding the name indicate the carbon atom in the double bond start. The carbon are numbered such that the double bond has the lowest number. In this way, 1 butene, it is correct, 2 butene. Here you can see the ethene undergo rehydrogenation, it gives ethane. So, alkene will characteristically react with hydrogen to form corresponding alkane. Now, members of the alkyne groups have the triple between the two carbon atoms. Two hydrogen atoms have been removed from each of the two adjacent carbon atoms, therefore allowing two adjacent carbon atoms to form triple bond. So general formula is this: begin with the ethyne, that is acetylene. These are the members of acetylene. This is the conversion of ethyne to alkane. So derivative of hydrocarbons. Organic molecules characteristics depend on the number, arrangement, and types of atom. So functional group, any atom or group of atom, organization of the bond that determine the specific properties of molecule. Generally, the functional group is the reactive part of the molecule. Due to the functional group presents certain predictable properties ensured. So example of functional group include like double bond in alkene and triple bond in alkyne, chlorine atom, fluorine atom, OH groups, methyl group. Derivative of hydrocarbons are organic compound that contains atom other than the carbon and hydrogen. So alkyl halides. Alkyl halides have the general formula Rx. Chlorofluorocarbon is the best example. Chlorofluorocarbon dichloro-difluoromethane freon 12 extensively used in the past in cooling devices में CFC का use होता है. Alkyl halide, another example of alkyl halide is chloroform. So carbon tetrachloride was also used extensively in the past until it was linked to the liver damage. Drawing the constitutional isomer is examples. You can see the drawing the structural formula for the two alkyl halide isomer that have the molecular formula. So recall the carbon atoms form 4 bonds and hydrogen and chlorine atom 1 bond each. So draw 2 carbon and backbone like this, and then add 1,2-dichloroethane, 1,1-dichloroethane. In the same way, you can draw like 2 fluoropropane and 1 fluoropropane. The same way, draw the alcohol. Another common alcohol, ethanol. This is the ethylene glycol, 1,2-diethol. Now you know the amine. If one hydrogen replaced by NH2, then we have the methylamine, ethylamine, dimethylamine, and trimethylamine. So most simple amines have a strong odors. The odor give of raw fish is due to the amine, and it contains 2 particularly foul-smelling amines are formed by the decaying flesh, cadaverine and putrescine, 1,5-diaminopentane and 1,5-diaminobutane. This is the structure, and amines have the medicinal importance. Here is the carboxylic acid, formic acid, and acetic acid are example. Ester are suitable odors of the esters. Methyl salicylate, we call it oil of wintergreen. So formation of an ester. You can see the ester formation reaction of the carboxylic acid and alcohol give the ester and water. This is the common reactions. So writing equation for the ester formation, example, you can have acetic acid, you have the ethanol. In presence of sulfuric acid, this water molecules removed and ethyl acetate form. This is the formula of amide. So friends, I hope this video will be helpful to you. If you like this type of video, then subscribe my channel, and thanks for watching.